So one of the biggest problems with our ability to deal with climate change is the fact that we can't see our emissions. But if you could, it would look something like this. So I love this video. It's by Climate Visuals, and it shows emissions from New York City. So the day has begun. Buildings are buzzing with electricity. Transport is pumping. People are cracking on with their busy and complicated lives. And in the process, they're releasing CO2, which is depicted by these blue balls you see here. Now, each one of these blue balls represents 1 ton of CO2. And this is what just 1 hour's worth of New York City's emissions would look like if you could visualize it. And for reference, the average Scot releases about 5 blue balls each year, which is about a third of what the average Aussie releases. So well done there, guys. Now, if I had flown to this meeting instead of doing it from my home office, I would have released a whopping 6 blue balls just from the flight alone. And so this is what 54 million tons looks like if it were visible. This is 1 year's worth of emissions. And we're hearing a lot more about the need to reduce the amount of CO2 we release to the atmosphere, the amount of blue balls going around into the atmosphere, by weaning off fossil fuels and switching to green technologies. But there's another aspect that we're not so much dealing with, which is what do you do with all the CO2 in the atmosphere, which will be floating around up there for hundreds of years, which is about bringing it back down to the ground. And it's a natural process that is done by plants called biosequestration, where they take up CO2, they keep carbon, and they release oxygen. And many of us think of trees when we think about biosequestration and carbon drawdown. But we've learned recently, well, about 10 years ago, we've recognized that our oceans and coasts do this job very well. And we call carbon capture and storage by the oceans and coasts blue carbon. And why? Because the oceans are blue. We call terrestrial carbon green carbon. And there are some other colors too. But when you hear people talking about blue carbon ecosystems, what they're generally referring to is either seagrass meadows, tidal marshes, or mangrove forests. And why? It's because these 3 ecosystems, even though they occupy less than 1% of the seafloor, they sequester more than half the ocean's carbon. So they're really doing a lot of the heavy lifting when it comes to ocean climate change mitigation. And when you put them head to head against these green carbon ecosystems, and you compare their carbon burial rate, so the rate at which they draw it down into the ground, as MacLeod et al. Did in 2011, you find that they sequester carbon 30 to 40 times faster than green carbon ecosystems. So they have really fast carbon burial rates. And perhaps more important, and this is probably one of the reasons why I love them so much, is that they store the carbon in the ground for millennial timescales. And this is really important because a lot of the offsets that we see in the market that we can purchase to sort of pay for our carbon sins, they're only storing carbon for decadal timescales, which is not really fair when you've taken a fossil fuel out of the ground, you've taken it out of retirement where it's been there for millions of years, you're burning it to fuel your life, and then you try and offset it with a temporary carbon measure. So these blue carbon ecosystems, they store the carbon long term. In fact, these ecosystems are what created fossil fuels in the first place. And in case you missed that, I'll say it again. These are the ecosystems that created fossil fuels in the first place. And they also offer us some other great co-benefits that I'll talk about as well. So it sounds great, right? These blue carbon ecosystems, but they're not considered a very lovable ecosystem. I love them, many of you love them, but the general public don't see them the way we do. In fact, many people regard them as the armpits of our coast. How dare they, I know. Even in the English language, we see a negative image of wetlands. We get bogged down in detail. We're swamped with work. We've got the mythical Beowulf and Boogeyman. They came from swampy wetlands. And so if you're a wetland or a blue carbon ecosystem, what if instead we viewed these ecosystems as new weapons in the fight against climate change, with the ability to help reset our planet's thermostat? This might remedy their apparent lack of charisma and help us inject some much needed resources into their protection and restoration. So step one, quantify blue carbon. Or more specifically, we wanted to know, where are the blue carbon stocks and why? Are we losing blue carbon under business as usual? And what are the opportunities for restoration? And so in this talk, I'm going to be covering some of the lessons we've learned from Australia. Now, Australia is 100 times the size of Scotland in land area. But interestingly, and I only just learnt this in preparing for this talk, our coastline is only about double the length of yours. So you've got so many locks. It's wonderful, super exciting, and I hope to visit when this bloody pandemic is over. So this was the first national inventory of blue carbon ecosystems published in the world. It was Serrano et al. Our government threw millions of dollars at this research. And normally, if I was giving this talk for an Australian audience, I would do this, huff and puff speech about, oh, we've got all this blue carbon, how wonderful are we? But I'm not going to do that. I'm not going to go through the various stats. What I want to do is comment on the process we went through and share some of the lessons we learned. As I understand it, many of you have or are planning or are doing similar sorts of research at the moment in the UK. So we first worked out, how much blue carbon do we have? That's called the stock. It's basically what's been accumulating by these ecosystems over millennial or geological timescales. Then we worked out the sequestration rates, so the rate at which the carbon is being drawn down into the ground by existing wetlands. And these videos show some of the lab and field work here. We then did some modeling to look at the drivers of blue carbon. Why is this more blue carbon in some areas than others? And with that, we were able to generate national scale heat maps to communicate where the blue carbon is around Australia. So Australia has a heck of a lot of blue carbon, but we weren't patting ourselves on the back for too long, because it occurred to us that if we are losing blue carbon ecosystems, we could be losing blue carbon. And in fact, if we are losing blue carbon ecosystems in Australia about 1 to 2%, it might not seem like much, but when you crunch the numbers, if you're losing carbon from those systems at 1 to 2% per year, it's about an extra 10 million cars on the road in Australia each year. So this terrifies me. So my colleagues and I, many of us, started to look at, is there really evidence that when you disturb and deteriorate coastal wetlands, you trigger release of ancient carbon? And so we, set up this hypothesis that maybe they act a bit like a carbon bomb. And I know that sounds a bit sensationalized, but we were running with this potential theory as something we should be concerned about. And unfortunately, we were right. Physical, biological, and chemical forms of disturbance have the ability to deteriorate the capacity of these systems to act as carbon sinks. So in one example here, you see seagrass meadows where we observed thousands of years worth of carbon lost after these seagrass meadows were physically disturbed, and it only happened over a course of decades. So it goes out much quicker than it goes in. And throughout the world, we observed that loss of top predators, apex predators from the food web, they had these cascading negative impacts that ultimately trickled down to the amount of blue carbon that was being sequestered. And then through eutrophication, which is something we see all around the world with nutrient runoff, in some areas we saw up to a 100-fold weakening in the capacity of bays and estuaries to sequester carbon. But one aspect that is still important here that we really struggled to address, it eluded the blue science community for quite a long time, is how much of the carbon that you lose actually ends up in the atmosphere as CO2, because that's what's really the important part. Now, as you see here, this is what it would look like if microbes were munching up carbon and releasing it as a greenhouse gas. You can actually set it on fire. It's flammable. That's methane in that video instance. So I applied for 5 years to the Australian Research Council to fund this work. Knockback after knockback. Finally, they funded it in the last round, so I'm pretty pumped about that. And already with this research funding, we're making some really interesting discoveries. And just one example I'll give you here. We took these blue carbon samples from 1 meter below a really old seagrass meadow. And what we did was we wanted to look at whether that really old blue carbon is vulnerable to microbial attack. We age dated that carbon using carbon-14 and found it was 5,000 years old. We also analysed the microbes that were associated with it, and we found that many of them were dormant, inactive, asleep. We also looked at the chemical characteristics of that ancient blue carbon, and it's what you would classify chemically as really recalcitrant. So to a microbe, it'd be very hard to eat. It's like eating rocks. And so we started messing with this blue carbon in several ways. One of the things we did was we warmed the sediment, simulated global warming. Nothing happened. Microbes didn't kick into gear. But then we exposed that ancient carbon to oxygen. And what we saw was you get this massive breakdown of the blue carbon. In fact, we saw a 34 to 38-fold increase in carbon breakdown when we exposed this ancient carbon to oxygen. So our current working hypothesis is that oxygen is one of these master control switches over breakdown of ancient blue carbon. And it really gets you thinking about things that could happen in our coast that could lead to more oxygen penetrating the sediments, whether that's erosion from increasing storminess or dredging or any sort of activity that causes oxygen to be exposed to these sediments. And then we move into the next phase of research. And so we found at this point, we've got lots of blue carbon. We know that we're losing lots of it. But then what do we do that's different to business as usual? And this is where, for me, things get really interesting. So carbon is a commodity like any other. And internationally, we've seen carbon markets going absolutely gangbusters. And you probably remember just pre-COVID, we were seeing a big corporate almost every week announcing their pledges to go carbon neutral. We had Amazon, there was Google, there was BP, and many analysts have been saying for a while now that carbon could become one of the world's biggest commodity markets. Now, in a carbon market, you can get a carbon credit for doing one of two things. You can avoid emissions, or you can get a carbon credit for doing something to the landscape like restoration to increase the amount of carbon drawdown. And by the way, this video is just a stocking filler. It has nothing really to do with carbon additionality. It just shows the research in action. And I would have loved to have replaced this video with some of the data that's about to back up what I am about to say, but the work is currently under review, so I'll just verbally give you the main findings. So we call this additionality, doing something different to business as usual to get basically a carbon credit. And when we modeled blue carbon additionality opportunities in Australia, if we protected and restored our blue carbon ecosystems at wartime speed and scale, as unrealistic as that might be, but we estimated we could roughly double the amount of blue carbon in Australia. And this doesn't include seaweed opportunities. And then globally, we have another manuscript currently under review where we've estimated that blue carbon, if we really capitalized on it around the world, it could help offset 3% of current global emissions each year, with about 70% of that coming from restoration and the remaining 30% from protection of existing wetlands. So as a PhD student, and when I was an ECR, I probably am still relatively early in career, but I would often sign off with my papers as, we recommend policymakers should blah, 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 land managers should restore, policymakers should change policy. Some of you might have done this as well. And it sort of occurred to me that I have really no idea what I'm talking about when I'm saying that. I've never restored a seagrass meadow. I've never been involved in a change to federal policy. How hard is it, right? So my lab and I, we wanted to give ourselves a reality check of what it's like to do restoration. And so we applied for a grant from our state government to put our science into on-ground action. And they funded this program. It's called the Victorian Coastal Wetland Restoration Program. And the funding came from their pool of funds for biodiversity to try and avoid loss of any further species in Australia. It's something we're quite embarrassed about. Actually, this photo that you see here on your screen is taken from one of the last remnant habitats of the orange-bellied parrot. I'm not sure if any of you have heard of the orange-bellied parrot, but it is one of, if not the most endangered species on the planet. It's estimated there's only about 50 of these birds left in the wild. So there are 4 parts to this program. The first part is developing restoration action plans to convert these industrial wastelands back into wetlands. And in doing so, what we're trying to figure out is, what are those ecosystem service trade-offs you get under different restoration scenarios? And the method of restoration that we're proposing here is reinstatement of tidal exchange. So that photo on the top right, you can see a levee, a dike. We've got these all around the Australian coastline. They were put in by European settlers to stop wetlands basically functioning and to control water levels. So we want to bring back natural tidal exchange. Oh, for any of the movie buffs among you, this site here that you see was had one of the scenes from Mad Max 1. Mad Max being played back in 1979 by Mel Gibson. And this was the scene where his wife and their daughter go to get an ice cream from the ice cream shop, and they get chased by the toe cutter gang. So program number 2, this is using low-cost fencing to exclude cattle from the shoreline and passively restore salt marsh. And I know you guys are the kings at doing this sort of work. This photo, I think, shows how effective it is for us. On the left-hand side, you have farmland that is still actively grazed by cattle, and then we put a fence in, and then on the right-hand side, you have this gorgeous salt marsh that's really coming back on its own without any form of intervention, simply by excluding the cattle. We're now looking to upscale this program, this work, and we estimate that we could restore an extra 30,000 hectares along my part of the coast here, which is just a very small part of the Australian coast. And doing so would draw down about an extra 27,000 tonnes of carbon each year. Not bad for $17 per metre. That's what we pay for fencing at the moment. The third program involves working with traditional owners to protect what's left of their cultural heritage, which is bound up in a lot of these wetlands. So Australia's Aboriginal communities have long regarded wetlands as vitally important for their livelihoods and their well-being. I mean, they're the supermarkets, they're the hardware stores, they're the pharmacies. That was where Aboriginal people spent and congregated a lot prior to European settlement in 1788. European settlers felt very differently about these systems. They were seen as unproductive areas of little practical value. And so they drained 8 million football fields worth of coastal wetlands, blue carbon ecosystems. And so we're working here with traditional owners, with the Aboriginal communities locally, to help protect what's left of these sites of really important cultural significance. It's the connections they have back with their ancestors through these sites. And the fourth program, and finally, is dedicated to community engagement, to engage our sponsors in the research itself. And this particular video is citizen science program we ran with HSBC Bank, where we took 500 of their employees in Sydney, Melbourne, and Auckland, and we got them out of their suits, we threw them in the mud for a day, and we also did some social science research to see how these immersive experiences affect them longer term. And there's some very compelling data to show that it does create long-term behavioral change. Co-benefits. I mean, not that you need it anymore at this point to love blue carbon ecosystems, but I do want to talk about some of these co-benefits. So we had this program, a 3-year program we've recently finished with the Nature Conservancy, looking at what we get from coastal wetlands in dollar terms. I've already covered blue carbon, so I'll put that one to the side, but we looked at fisheries, we looked at tourism, recreation, and coastal protection. And what we wanted to do was to put these values into spatially explicit maps. I love maps. They're one of the oldest forms of non-verbal communication. I've done a lot of travel in countries where I didn't speak the local language, and it is amazing that even though you don't speak the native tongue, you can point on a map where you want to go, and it cuts through, education backgrounds, age. People understand maps. So we wanted to communicate not just where the value is, but using heat maps, where the value is and how much value there is. So in the interest of time, I'm just going to race through some of the major findings we had. We looked at recreation. Now, I didn't think there was much recreation that happened in Australia's coastal wetlands, but it turns out there is a vibrant bird watching community that spend a lot of money to see birds in coastal wetlands. In particular, old, wealthy men. And so we tracked their activity and ran a bunch of surveys and interviewed them. And what we found was that in each visit, they were spending about $158. That was what was going into the local economy, which seems like quite a lot. And then we had this massive spike in the data where a group of bird watchers, known in the birding community as twitchers, flew in from all around the country, spending thousands of dollars, tens of thousands of dollars to see a duck that had turned up for the first time ever in Australia. They called this a mega twitch event. And this is what the duck looks like. It's very unassuming. Some say it looks like Danny Zuko from Greece. And possibly you're familiar with this duck because it's one of yours. Now, just to be clear, I'm in the bottom right-hand corner of Australia, and your duck flew all the way from the Northern Hemisphere, wasn't spotted on its way down, but it came all the way down to the bottom right-hand corner of Australia, and it settled in one of our sewage treatment plants. I think it might even still be there if you do want to come and get it. So that's ducks. Now coastal protection. Now here's where the numbers get really big. We put out pressure sensors in coastal wetlands to measure wave attenuation by seagrass, salt marsh, mangroves. And we found that collectively these three ecosystems are attenuating waves 37 to 71% along the Australian coastline on average. Mangroves in particular are doing a lot of coastal protection. And when you look at the value we get but in terms of avoided damages from these ecosystems and coastal protection, they're worth about $2.7 billion each year in terms of avoided damages. So makes you think about incorporating coastal protection values into our coastal insurance policies. And finally, and very briefly, fisheries enhancement. We did a bunch of studies, a few of them just been published recently using stable isotopes to look at the contribution that these blue carbon ecosystems are making to fisheries. We found on average, these ecosystems are contributing to 61% of the diet of fish that are harvested by our local fishermen. And this is what really excited me was we wanted to look at enhancements. So compare a seagrass meadow, for example, to an unvegetated area of bare sediment nearby. And we found on average in each hectare, you're getting 56,000 more fish per year than a bare sediment area. And that's contributing about $32 million to the economy each year. So that's it for me from the science. Now some acknowledgements. And I don't want to be facetious in putting up this slide, but it is really hard to acknowledge everybody that's contributed to this work. But this is the list of all the people who we've published with or had grants with over the past 10 years and what have made this work possible. It's been bloody good fun having such multidisciplinary research going on, very collaborative, exciting science. There's so many low-hanging fruits in the blue carbon world these days. But in particular, I want to thank my lab, the Blue Carbon Lab. These are the guys who are the science muscle behind all this work. I'm presenting the research on their behalf. I'll post in the chat box, if I'm able to, some links to some further work we've done that might be of interest to some of you, including teal carbon. We didn't get a chance to talk about teal carbon, but I know David said that you're not opposed to considering teal carbon into your marine science remit. But otherwise, thank you so much for having me as a speaker. I've really enjoyed hearing your talks, and I really hope to collaborate with more of you more often. And if you have any questions, I'd be happy to answer them.
Okay. Well, the first thing I'm tempted to say is, what do you do in your spare time? And the second one is just to emphasize the number of people who have enjoyed the visualizations and the way that you've presented this, which has been very clear. I will go to some of the questions on screen. If you have a question, please type it in, because even if we run out of time, then Peter may have the courtesy to address them later. So the first talk I'm going to go to is to Alejandro Gallego, who said, when companies or governments use carbon sequestration to offset, how can anyone guarantee the carbon will remain sequestered for a meaningful timescale? I don't know what he means by meaningful. How would you respond to that?
I think that's a really good question, because to be honest, international policy does not hold people to it. I mean, here in Australia, for example, and I think we've got similar times of permanence to other parts of the world, you can create a forest, and once your 25-year commitment is up, you can actually chop down that forest and start again. You could burn the forest and, well, you probably can't burn it, but you're not being held to lock up the carbon long term. So I think that's probably where federal level protection is needed, covenants on land, to make it more permanent. The downside of that is that pretend you're a farmer, maybe you're an asparagus farmer as we've got here locally, and you want to start farming blue carbon, not asparagus anymore. Well, after around the 25-year mark, you're not really rewarded for farming blue carbon anymore. The time is up. So I think in the blue carbon world, we're not used to long-term offsets, but that's something we need to start to consider more. I mean, this is a premium form of carbon. It's long-term carbon drawdown. We should be prepared to pay more for it and factor in long-term carbon credits.
Okay, thank you. I'll move on to Chris Leakey, who's asked, what were the behavioural changes that the bank employees reported? Were you able to follow that up?
Yeah, it's a good question. So you probably all know Emma McKinley. She's fantastic. Emma is the one who ran our social science surveys. And what she wanted to do, and what we did, was to not only just look at their response to blue carbon, because they're not really doing blue carbon things in their everyday life, but what they are thinking about is recycling. They're talking about with their friends maybe about climate change. They're making some decisions in their everyday life that make those simple contributions to reducing their emissions. So this was about improving climate literacy for a company that's spending $100 billion in sustainable finance. And we wanted to make sure that the decisions that are being made around the board table, they know how that could impact climate change. So what we did was to look at, we surveyed them before, immediately after, and 3 months down the track. And there is some very compelling data, stay tuned for Emma's paper, that shows that we do start to see people, many of them, probably women more so than men, but picking up on things that they had done still at least 3 months after they've completed the Citizen Science Day.
Okay, thank you. The next question is from Coralie Hunt, who thanks you for your presentation, but says, how easy was it to convince landowners to erect fencing to limit the grazing and help restore the marsh?
Yeah, good question. So we have not asked them to enter into a covenant or anything like that. We have simply said, hey, Joe, hey, Maggie, hey, would you like a fence? And a lot of them were happy to accept the free fence because already they're trying to keep their cattle out of land that is increasingly being inundated by sea level rise. Now, we've got a thing in Australia, a rule where the high tide watermark is, up to that point, is owned by the Commonwealth. But the high tide watermark is changing around Australia. So you've got farmers who are very concerned about the future of their land and the farmability of their land. So what we're trying to do is create some change in terms of land tenure policy to buy back that land, effectively turning lemons into lemonade by allowing farmers to farm blue carbon. So for a lot of us, I do not have connections with these local farmers. I could not knock on their door and ask for them to give up some of their land. But what we do have are number of partners around Australia who know these people. They're in those local farming communities. They have a cup of tea with them, pitch the work to them, and that has led to some very successful uptake.
Well, I noticed you're name dropping Emma McKinley, and she's just appeared on the chat, so she may be back in touch with you later. Debbie Russell asked about, I guess it's really about ocean literacy and that blue carbon isn't well understood by the public. And I guess you're just asking, at a large scale, how do you communicate that? Are these small localized events able to translate to a larger scale public information?
Oh, it's a good question. I mean, we had blue carbon appear on national television just recently. And if you keep tuned for a documentary called The Age of Nature, Irma Thurman is the narrator. It's coming out in the US next week on PBS, and then it's going to appear on BBC. But there is a 6-minute segment now there on blue carbon. I mean, a lot of people love Attenborough documentaries, right? You put Attenborough talking about blue carbon, that's how you get to masses. And then the people who maybe aren't environmentally minded, you probably get to them through financial means. You get to them through an opportunity to increase revenue for their company or to offset emissions or some sort of bottom line benefit to those companies. And so there's probably different tactics for different groups, I think.
Okay, thanks. I'll move to Flora Kent's question, which is which species, seagrass species, do the blue carbon figures relate to? And she obviously has our Scottish populations of Zostera in mind. Are they equivalent?
Yeah, so the work I presented in Jervis Bay, where we'd lost 1,000 years worth of carbon, that was from Posidonia australis. Very slow but robust, long-lived species, but it recovers really slow. It's only recovering through rhizomal growth. We're not getting propagules landing into these areas that have been disturbed. So it's growing back at about 2 centimeters per year from disturbance that happened 50, 60 years ago. It still hasn't recovered. The Zosterus that we have here, Zostera muelleri, seems to be much more resilient to change in one sense, but it's also quite ephemeral. It comes and goes as well. And then we've done a bit of work on deep water seagrasses. We found that seagrasses around the Great Barrier Reef, these deep water seagrasses, are locking up about 200 million tonnes of carbon each year. And we didn't think, given they're really small in stature, they would actually be doing much. But in fact, you can get detectable levels of blue carbon being bound by these systems compared to nearby bare sediments. Okay,
thank you. So we have an interesting question here, which is all about balance. And we always discuss this, but from Fabian Gross. He's mentioning the birds and then the people flying in to watch the birds. So what's the balance there between the carbon sequestration of the habitats and attracting all of these, you put it gently, rich white males, or possibly.
I mean, we're always making these tough decisions, right? And I don't want to feel guilty, when I drive the kids to their footy match or, going on a family holiday. I mean, I think that's really where we need carbon taxes, because, carbon taxes, I guess, they take that they take that decision away from you, right? If you ask the UK population, Australian population, do you want to stop paying taxes? No one will know if you've stopped paying taxes. We'd all stop paying taxes, right? You have to implement systems that penalise us when we have a negative impact on others in society. So, this is the same thing we need here with, so if you had flown in to see those birds, that you would have been taxed on the way by the taxi you took, you would have been taxed on the way by the plane flight for your carbon emissions. So basically every step in life that we have that contributes to emissions in the atmosphere, we're having to pay for those carbon sins, and that'll hopefully reduce consumption of greenhouse gas intensive activities.
Okay, I'm going to ask one final question from the list. We will collate the other ones and present them to Peter for his homework. And then we'll close this session, because obviously we have another session starting at 10:30. So I'll leave it up to Kathleen Haas to present the last question, which is more technical in terms of what happened to the dormant bacteria when ancient blue carbon was exposed to oxygen. Did they become active? And I guess the between the lines question, or did new populations of bacteria move in? And that's why the ancient blue carbon started breaking down. So was the red population the new population, or how was that working?
Yeah. So we did some community work that suggests there was a shift in the microbial community. So you've got anaerobic bacteria. They're not waking up, right? I think it's more that you've got aerobic bacteria kicking into gear. We did some metagenomic work, and we'd like to start to do some more metatranscriptomic work to see, what genes are we switching on and off, and who are those key microbial communities. But I mean, a heck of a lot more to go. I'm not a genomics expert. I really rely on colleagues there. So lots of questions there. I think it's just a big black box at the moment for us with the microbes and what they're doing and who's there and how they're doing it.
Okay, in that case, I will draw this session to a close, but just to thank you sincerely, Peter, the breadth of what you do. And I think that turning the science into policy and the behavioral change is something we can all learn from. A lot of us sit on our benches doing science, but to get it out there in order to make a substantive change in societal behavior is a real challenge. And it seems that you have managed to find a way to do that. So thank you very much for the talk today, and I hope you'll be able to join us through some of the rest of the sessions of the conference. Thank you.
I'll be there. Thanks, David. Thanks, everybody, for listening.